Welcome back, everyone. I'm here to welcome you for the last time today. Closing the cloud and streaming track before the final keynote is Tim Spann, who is a developer advocate at Stream Native, the folks behind Apache Pulsar. If you watched the previous session on Apache NiFi, Tim's talk is a great follow-up as you'll be exploring how to build end-to-end streaming pipelines in cloud environments, hybrid and beyond. This will be a live talk, so Tim will be available at the end to answer your questions. So just drop them in the Q&A section as he goes along. Welcome again, Tim, and take it away.
Thanks a lot. Yeah, today is streaming with Pulsar and NiFi, so you'll get to see that continuation. I'm Tim Spann. I'm a developer advocate for Stream Native, the company behind Apache Pulsar. If you've seen my talk last year, was all about NiFi because I came from the company behind NiFi. I haven't given up on any of the rest of the Apache streaming community. So it's Flink, Pulsar, NiFi, maybe Spark in there sometimes. Whatever you need to get the use cases solved. Today, hopefully, if everything's working, it's kind of early here in the East Coast United States. If everything is working, we'll see IoT ingest with a bunch of different sensors, bunch of different devices. Lots of issues there potentially because you have different formats of the data, different protocols, different devices. Lots of things can make things difficult. And we'll show some other sources. And again, when we do the Q&A section, maybe we'll show some additional. But I've got transit data, got some REST data, stock data. Data is just data. When you have a flexible system, you'll see it doesn't matter much. It matters more what do you want to do with it, where it's going, those sort of things. Obviously, if you're working with any kind of data, you know that there's a lot of things that make things challenging, difficult. Things like you have a lot of different sources, they have different formats, they're very fast. That makes things difficult. You may have to constantly be working with different types of data, as you might have seen in NiFi. NiFi is great for getting those data, getting them cleaned up into some manner and get them into the stream. Real-time insights is constantly something people are thinking about is how do I look at this streaming data, make real-time insights on it. It's one thing to get the data fast and have it go somewhere, but to be able to get queries on it while it's happening, very important. Finally, these are happening in different clouds, different availability zones, maybe on devices. It's bouncing around between different networks, different applications, different platforms. Being able to see what's going on for the whole end-to-end stream is difficult. So something to think about when we're building these applications. So I've kind of put together some of my favorite open source tools. I call it the Flip or Flip and Stack. It's focused on data engineers, but if you're a data scientist or a programmer, you're probably dealing with data. You can call yourself a data engineer when you're working on a data engineering problem. Obviously, there's a ton of things going on. Most common is you just want to do some kind of ETL or ELT, get the data from somewhere, do some kind of transformation, get it somewhere. Most people know some Python or Java. That's enough with some SQL to get things done here. If you're my cat, you're also into ETL, but it's slightly different. He's not very good on programming, but he's very questioning on all the money I'm spending on my different cloud resources here. Now, another part of this, it may not be applicable in your current use case, but this will be becoming more and more common as part of a real-time stream. There's going to be some machine learning. There's going to be some deep learning, and that could be, running wherever you need it to run. I've got some NVIDIA devices, so they've got powerful GPUs. I'm going to run some of that right at the edge, right when that data is born. That's an easy way to do it. but often I don't have those resources, or as it comes through the system, more data accumulates around it, kind of a snowball of data. So I might run that in NiFi. I might run that when it gets to a Pulsar topic. I could do that with a function. I might do that with something like Flink or Flink SQL as it's in the topic as events arrive. I could do that when I consume the data out of Pulsar, whether that's through a microservice, standard client, or a Kubernetes-based function mesh. You've got options where you run these. Now, one place you can run them is in a fully set up platform. Stream Native has a platform, so you don't have to try to run Pulsar on your own. It's great developer experience. I run Apache Pulsar standalone, but there is a lot of manual work there. You don't have a UI to manage it. It's it's doable, but having someone manage all that, manage the Kubernetes environment, manage the different clouds, make sure your storage layer is proper, you have enough bookkeepers. One thing I want to point out really quickly, if you haven't seen Pulsar before, it has a separation between compute and storage, which is a very nice feature because of that isolation. You could tier out storage very easily to something like S3, so you don't have to worry about throwing away messages when you get too much. Keeping them and having them stored in cheap storage is nice feature. So we mentioned flipping. So Flink, Pulsar, sometimes NiFi. I'm a big NiFi advocate because it has a lot of uses on getting your data ready, acting as a gateway, moving it to different locations. So having that work along with Flink and Pulsar to do some of the entry level, getting that data cleaned up and ready is a nice feature because I don't have to write any code. That's something I like, is to be able to quickly get something up there and not have to spend days writing code. Now you already saw a NiFi talk, so I won't go too deep on that part. But a couple of the features here that are important for what we're doing: guaranteed delivery, data buffering. I'll show you quality of service. The data provenance really is that visibility. Those ones are pretty critical to everything we're doing. Scalability, if you couldn't scale out, just running it one node may be useful, but typically I'm not going to have just one device somewhere. I'm going to have hundreds, thousands. When you have a ton of different devices, it could be a much different story than if you have just a handful. So having that large amount of data there is important. That you need to be able to scale up to that, whether that's just gigabytes, terabytes, petabytes, millions of events. All that's possible. Scale very linearly, as many as you need there. What's cool is you can extend this very easily. I've written a number of processors. You can too, whether that's to connect to, some data system that you have, maybe it's unique to you, or maybe it's, just something that isn't in the community yet. Makes it very easy for you to extend things, add your own processing, add your own capabilities there. Again, if you like programming, this is a great way to add some of your code you already have. Very similar to, say, Spring Boot. It does have to be in a JVM language, preferably Java, but there's some other ways around that. Again, you may have seen these slides for NiFi. Does a lot of features, and we'll show you some today as part of various demos. So you see, data in action coming from, REST endpoints, coming from sensors, wherever it's coming, wherever it needs to go. Pretty straightforward. Now, Pulsar, you may never have heard of, never seen before. It is the new guy on the block. Now, when I say that, part of that's joking because Pulsar has been around for a number of years, but it's just now starting to get to the point where people are seriously noticing it. And one of the reasons is, another open source Apache project, but cloud native distributed messaging and streaming. That verbiage is not there for no reason. It is messaging as you think of it when you've been doing ActiveMQ, SQS messaging, where, it's JMS. I put a message in there, I can have multiple people read it. Ordering is, not as important as using this as a work queue or as a way to distribute messages to a lot of workers to, store your data. Lots of different uses for these, often used in a lot of enterprise applications. So Pulsar as a unified messaging platform does that part of the problem, which is important, but it also does the data streaming part. So, what you traditionally do with Kinesis or Kafka, you can also do with Pulsar. These are all configurable options on, what do you want each topic to do? Is it a message queue? Is it for data streaming? Lots of variants possible. Nice to have this in one scalable queue. And what makes that even more powerful is it has geo-replication built in. You don't have to pay for some special add-on. It's part of the open source project. So I can replicate the data wherever it needs to go. So I can push it in over here from a JMS app, and it may look like, those traditional brokers you're used to, because we have multiple protocol support, which again is pretty intense. So I can just have it act as if it was that broker I was using before, get that data in there, geo replicate it around the world, and maybe someone's consuming it with one of these other protocols. Now, obviously, we would like you to use the native Pulsar protocol, but you may have a lot of legacy code out there, or code may not support that. Like some of the edge devices, they're going to push MQTT. So having Pulsar act as an MQTT broker like we're doing today is really important. There may not be another way to do that. It may take years before you get these various edge devices to upgrade their messaging protocols. So those options are there. I could turn that on. I could turn AMQP on. I could turn Kafka on. And you could just have this one place where you have universal messaging. Makes it very easy to get what you want done, when you're ready to do it. Very powerful. Now, if that was all the features, I'd be pretty happy. But you've got scalability and multi-tenancy. Scalability, of course, that's table stakes. Multi-tenancy is not always, and that's kind of difficult in a lot of streaming systems. So this doesn't mean, okay, like if I go into NiFi with permissions, I can make sure other people don't see things. But Pulsar is designed so you could set up a tenant, and that can be completely isolated, secured from everyone else. And then underneath it, it's its own namespaces and topics, and they don't collide with anybody else. That is important. So I could have host multiple organizations, each gets their own tenant. Under tenant, different namespaces, you get different business units. Makes it very easy to figure out how to bill, how to segment, how to secure. Very nice features there. We mentioned that tiered persistent storage. We can also have things be non-persistent, something that you don't see in some of the other messaging. Sometimes the messages, if I get it to you, um, I just want it to be live while it's in transit and then go away. I mean, it could be like one of those messages, just like, "Hi, I'm available. This app is alive. It's alive." Don't store that message. It's always the number one, except for one time a year. Save your space there. Pulsar connectors, and I'm using one today. So what's nice is with these connectors, configure them. Make sure I have the executable there downloaded from either the Stream Native Hub or Pulsar or your own. Pretty easy to write. You put it there, configure it. When data arrives in that topic, automatically gets sent out to that sync, or it could be a source and syncs. Pretty easy to configure. Again, another way to do things with no code or low code. Nice way to get your data in and out. There's a full REST API, and it's not just for operations. You can use this to send data in, get data out. Very full metrics there, full administration, all that you'd expect through the REST API. Multiple powerful command line interfaces for doing everything from consuming and producing, administrating, every feature you need to do. What I like is you're not stuck in one language to write your clients. There are a lot of them. There's a number of them officially supported and a number of ones out there in the community. Everything from NiFi to Python to Go to Java to Scala, Node.js, as we mentioned, the REST API, WebSockets. Whatever is optimal for you, you have it there. As opposed to some other messaging, different kinds of subscriptions depending on, do you want to share the data, how many people are getting it. Lots of ability here for you to decide how you want to get your data, how you want to send your data. And another feature I liked, as opposed to coming from the other worlds, built in is a schema registry. I don't have to worry about running something different. It is so well integrating, sometimes you don't even notice it. It's just very helpful. Cluster is slightly complex, which is why you might want someone else to run it for you. It's kind of the minimum set you would need to do this if I'm going to have compute and storage separate. So Pulsar, I've got that, handling all the message routing, stateless. Bookkeeper stores my messages, keeps track of where we are. Zookeeper, like it does in a lot of different places, make sure I can figure out what the metadata is, find out when nodes come in and out, some basic management. I know people have been wanting to get rid of this from some clusters. It's nice to keep the separation of what things do. Is who should run that? Who boots the booter? I don't know. Lots of APIs here. I won't spend too much time here. If you like to write code, there's a lot of places where you can write code. Very nice there. We mentioned subscription types. I don't want to dwell on that, but there gives you options of how you get data consumed. You have options. It's not like this is the only way you can do it. There are multiple ways, and they give you different functionality based on what your requirements are. This is really nice to have. Sometimes you need guaranteed order. Sometimes you want a lot of people reading the data because you just need to read that event and immediately do something and not have to worry about, okay, I got to filter this through an order, because that guaranteed order will slow you down. Sometimes you don't have a choice. Sometimes you do. You've got options there. Just go through that. We mentioned Stream Native Cloud to host it. It's not just Pulsar, it also runs Flink SQL, which is a really nice way to start doing those analytics on that data while it's in stream. That is a very useful feature there. Runs cloud native. Again, having that separation of compute and storage really enables that. Built to run on containers and Kubernetes, so very easy to scale that out. Has a nice architecture underneath the covers. I mentioned those syncs. I just wanted to give you a little more idea of how they work. There's one for cloud storage. This is nice because, obviously we mentioned that tiered storage. This is separate. I want to take a specific topic and get it into S3 exactly once, just when the event arrives in the topic, send it out there. Supports a couple different data formats, a couple different ways to do partitioning. This is a nice way to do that. This is, you could, extend this if you have different clouds we don't support yet. I didn't put even a small subset of the different syncs out there, but just to give you an idea, it's what you'd expect. The popular NoSQL stores like Mongo and Redis, different cloud resources, regardless of if it's Amazon or Google. You can go to the site and see more. It works as you expect. You have to put in the connection information. You have to put where you want it to go. Usually a topic will map up to a single instance of something like a bucket or a table or a collection. whatever the nomenclature is for, a single grouping of some set of data there. See if I create a duplicate. So this is my architecture for the diagram for my demos today. We've got a little bit of Flink in there. That's not too critical. Really, today we're talking about getting the data from places, having it come into the stream and get it stored somewhere while we do analytics while it's moving in. Bunch of different devices. I've got some Jetsons, I've got a Xavier, a Raspberry Pi. Some of them are pushing through native Pulsar. Some are doing MQTT on Pulsar. One's doing WebSockets. Some are going through NiFi, some are just going through Pulsar. Lots of options there. Got a couple of Pulsar syncs. Some of the companies I typically push this data to are on the other end. Lots of different data stores out there, especially good for IoT are some of the ones listed. We're showing you a simple one with PostgreSQL today. It's very easy for me to run one of those in the cloud and try to keep it all open source today. Makes it pretty straightforward. Like I said, the nice thing with Pulsar is I don't have to think about if if I'm going to run out of data, do I lose messages? How do I decide what messages get removed? Just get that offloaded. And if you want to query that data, it can be pulled from S3 as part of those queries without you really having to think about it. So you've got batch and stream. You don't have to think about them as much as separate things. Flink could do part of it. Pulsar could do part of it. Really depends on your use case. And that's where I'm sure a number of questions might come up of, when should I do one versus the other? Should I use something like this for a batch ingest? When do I use NiFi? When don't I? Which protocol should I use? There's a lot of different use cases. I have a lot of different data here. This is pretty typical. If you do an IoT, if you can format your data in JSON, it will make your life easier for going into different tools, whether it's NiFi or Flink or Pulsar or any other Spark, wherever it may be. If you can get it into JSON, that's a good start. That's typically accepted by most streaming systems. And then if it needs to get converted to Avro or Parquet or some other format, from JSON to that is usually something tools will let you do without too much heavy lift in there. If we're using, say, Stream Native to view the data, I could see that JSON data very easily while it's in the topic. Not too hard to do that. Hopefully I didn't bore you too much with slides. We got to have some there, so you have something to take away and, something to reference where things are. I'll show you the demo now. I have links to every demo in here, all the different source code, how you set things up, lots of different details around that. So if you have any questions, definitely ask them at the end. If you want to start getting them into the chat early, I'll keep an eye on them while I'm going through the demos. If I could show you some of that early, I will. So let's get to the demo. First off, I did mention those GitHubs. They're linked. I'll have all the slides and all the information on this talk in my speaker profile. And I've got various GitHubs for different parts of the demo. And they're pretty solid. If you see something missing, do a pull request or post an issue. I try to put everything I can in there, from the Python code to schemas to scripts to Java code, and fairly step by step on how you build things, how you run them, how you monitor them, and other resources to go deeper. Same here for, how do you build a sync? How do you list it, get it? Command line is the easiest way to do that, unless you're using Stream Native. And then you could just go to the connector tab and press a couple of clicks, but depends on your environment. I wanted to show you when I start getting messages into, say, Stream Native's hosted Pulsar, pretty easy to navigate to see where you are in the data and being able to see the details. And you can add, Pulsar allows you to add various extra properties. Like here, I added one for tell me what the device was. I like doing that so I have, just a way to augment and tell me what data is. And, you can add whatever you want in your data. One thing I'll recommend if you're doing IoT, try to put in a unique ID. If there's not a natural one with your data, generate one with UUID creator, some random number there, some sequence, something. Make sure you have as many timestamps as you can as you go through different steps. Put data that identifies the device. Maybe it's only one device today. Very shortly, you will have more than one device. MAC address is good to have in there. I like to put the status of the device as part of my data. Maybe you want to keep that separate. That's up to you. I like to keep it together unless it gets too big, but having that knowledge of how much disk space I have, how hot the CPU is, that can be very important and maybe something I want for my analytics. Being able to know, predict when that device may fail, having that as part of the data, is very nice for doing that, like say that Flink SQL analytics. And if you don't want to store that data with what's the valuable part of the data, which is probably that ID timestamp and, whatever the data is. For this one, it's the analytics on an image. So I might just want the image, how much time it took. The rest of that, I could pull that off. NiFi can do that. Flink can do that. Pulsar can do that. So if you want to shed off those extra fields, once you've run those initial alerting and analytics, you can. Something to think about there. I mentioned the Flink SQL. I navigate through my auto-generated catalog, pick out which table I want, look at the fields, and then just run my Flink SQL there. Pretty straightforward. There's lots of different places I could run Flink SQL. I could do it from my own interface through some other cloud interfaces, just to give you an idea. So let's go to the least interesting part of this is I'm just going to start my data. I had this running before, but I tend to run out of disk space here because I'm running a lot of sensors. As you could see, this is, doing thousands of events a second. A lot of my environment is on my desktop here. So that's a lot going on. Let's see, as data comes in, this is one of my syncs here. This one is reading data from one of the syncs, one of the topics, and syncing it right to a table, just to give you an idea there. Next up, we're going to go to NiFi, and I'll show you how NiFi interacts with Pulsar. Lots of different ways. So I have one of the NiFi devices is sending MQTT messages out. So NiFi is going to receive that through Pulsar is acting as my MQTT broker. Again, I have an example here on this device. Let's show you that source code. I just want you to see over here. Yeah, I'm calling using the MQTT client code to send my sensor reading right into Pulsar. That is a nice feature. I could also do that for Kafka. I could do both at the same time. I could send it to Pulsar natively or one of the other protocols. But I wanted to show you MQTT, as that's a pretty common one. And when I'm consuming it, wherever this client is, it doesn't really matter. It looks like Pulsar to me. I put the name MQTT in there so I know that, yeah, this was one of the MQTT filled topics. but it doesn't matter once you're using it. It's just a regular topic, which makes it nice. You don't have to think, well, if it's MQTT, I've got to do something special. If it's JMS, I've got to do this. If it's Pulsar, this, all the same to you, which is really nice. I got the subscription type in there. This is a new uh, NiFi connector for Pulsar that my friend David wrote. It's got the consume and the produce like you'd expect, and one that does records. There's a new release that will be coming out soon. Once that's available, we'll make sure everyone knows about it and maybe support that through some of the NiFi channels. I'm working with my friend Pierre on that one. Uh, it's a great, easy way to get the data out of there. And then, as you know, with NiFi, very easy to take data of one type and convert it, maybe run a query on it while it's happening. I don't want to have it too humid in my room, so I'm checking the humidity. If it's above a certain thing, let me send that alert somewhere. Again, we mentioned those queues. Every step we've got a queue. So this data is waiting till I decide what to do with it. Nothing interesting in that one, but we got that alert there. And then the data here, these are the fields I picked. I can choose with that select statement different fields and just grab the ones I want. Again, a nice feature with NiFi. And I can just grab one row or I can grab 1,000 rows, depending on how the data is coming in, what you want to do with it. And again, I could drop out some of these extra fields here, depending on what I want that data to look like. Here I'm showing you one way to take sensor data and get it into a cloud data warehouse or cloud database or whatever you're going to call it. Most of them have a JDBC interface. Here I'm just taking that JSON coming in, putting an insert, giving it a table name and a connection pool, and that's it. It'll start storing data in there, and I don't have to know what the fields are. It'll automatically map that for me. And that is this data here. And this is the data that loaded a few minutes ago. That's pretty current here. Yeah, here it's my time here is 8 a.m. And you can see that's 8 a.m. here. And that data just came in. That's when it was the IoT sensor was processing it. This is when we stored it pretty quickly. That's why you have those timestamps to know, well, was that data sitting on the device a while? Did that just get run? Lots of different data points you may have there. That's why I like to have as many of those timestamps and run times as I can, because sometimes things are quicker or slower, and that might be something you want to analyze. So that's a typical use case. Get the data from the devices, and this could be thousands of devices. Pulsar can aggregate that for you. You filter it. This could be, we could have a function in Pulsar that, tweak this down before we even got here. So you might not know. This might be pre-processed by Pulsar functions or microservices already. And then here I filter it with NiFi, send it to my data store. That is, you would think, as easy as it could be, but that's not the case. We have this one here does this without NiFi. This is just as IoT records arrive, they are automatically sent to Postgres as part of a sync. And that's that sync I have looking at the status here. And it's pretty straightforward for you to do that. Another record showed up. If we look at the code here to set one up, we've got a config file. We tell the namespace, there's a connector there, a topic config file, the parallelism you want, and it just runs it for you. And it's really just what's the URL, the data store, what's the table name, what's the login information. That's all you need to configure, and then that just runs for you. So as data gets pushed there, it'll just do that for you. Now this is that Raspberry Pi one that's going through NiFi. I'm doing about a record a second. I'll stop that for now. I've got another one on an NVIDIA device. This is running a camera over here, taking a picture of my screen. Not very exciting. No cats in my office today, I'm afraid. And it's grabbing that data and sending it to a couple of different places. I've got one that's going to my sync in Stream Native and one that's going to my local Pulsar cluster. Now, I could have had it just go to the local Pulsar cluster and have it geo replicate up. This is easier and also lets me decide, how I want to play around with the demo. Do I just want to be local? Do I want to go to the cloud? Do I want to do both? Pretty straightforward. And the code here, again, is all available. But just to give you a quick idea of my, this is a little hacky because I wanted to keep the code that goes to Pulsar separate. So I run my existing application that does deep learning, get the results. They go to a log file. And I have 2 Java apps that read from that log file and send it to different places. One to my local cluster into one topic, one to a different topic in my cloud hosted one. Different ways to do that, but just to give you an idea here. This is another one that's going to a different topic. Uh, Again, pretty straightforward. The one thing I like about this is this one is Go. The other one was Python, and that one we just saw was Java. It's pretty straightforward to do that. This is some sensors running on a different NVIDIA running. And here, if we take a look, I can run my little Go script here that's very quickly reading from a log file to grab all the sensor readings. It'd be even faster if I wasn't printing it out, but if it's running and I can't see the output, doesn't make for a good demo and doesn't let me see that things are going on. I want to be able to see data's happening, things are going on. That's pretty fast. That's why I kind of like the Go topic there. You see current status of what's going on with your data as it's coming through. And then we'll go to another NiFi example. We still have some time. I don't know when we want to go into Q&A. I guess maybe 5 minutes before. And then I'll keep this up and running so we could answer questions through the system. This is an example of getting REST data for stocks. I get the data. I fork it out. This one's important because the data has got 2 sections, one metadata, one with a whole bunch of separate values. I break those out and then I convert. Again, I can convert from CSV to JSON, XML to JSON, those sort of things. I add those fields that I tell you I really want to have. Add a date time, add a key so I know what stock it is, a timestamp, and I add a unique ID. NiFi would generate a unique ID for you for each event or file that comes through the system. It makes it very easy, and this is a nice piece of NiFi doing ELT. Now, another thing that if you didn't see in the last talk, I'm not sure if he covered lookup records. Lookup service, really nice way for you to augment your data. And I think one of the key things you could do here is having these different lookup services. So I can find a way that I want to map this data. I could use Elasticsearch, JWC Store, Couchbase, HBase, Mongo, Kudu, REST. And REST could point into any REST service in the cloud or for, ML, whatever you may have there. Makes it easy for you to augment your data, add fields. Yeah, I added this temporarily to show people how easy it is to add different endpoints, and it will quickly fill up the data, but nothing's wrong until we hit the max limit of that data. When that happens, back pressure starts pushing you back up to tell this guy stop processing, and then this one will fill up, which this one has a pretty big back pressure I've set. And I could set that at the level of the entire group of this module here, which is a nice feature. That way I won't get overfill if I stop something. I might be deciding I want data to wait for some reason. Like here, there's a lot of data waiting for this downstream, and I don't really need that right now, and I'll just get rid of those. Pretty easy to do, and I could do that programmatically if I wanted to. Depends on your needs there. We mentioned custom processors. I wrote a couple of these. Just put them right here. If you if you want them, you could just grab ones. These are all open source. You see here, one to grab camera. I've got some deep learning ones. Very easy to write these, and often it's just a thin wrapper around some open source library. Like Twitter has a great library for pushing out tweets. I wrap it, very easy to make calls. You already have code somewhere in Java. You could call it from a NiFi processor. Makes it easy for you to add your own custom functionality. Let's show you another example here. We have some time. I don't see anything in the Q&A or chat yet, but if you have anything, drop it in there. I've got different use cases here. I've got some transit data, and it's in RSS, which, again, not my favorite format, but that RSS is a type of XML. Read the XML, convert it to JSON. Here, if I wanted to limit some of the data while I'm doing that transformation, pop it in there. Also, I could pick out the fields I wanted. If I only wanted a couple of those fields, or I could add multiple queries. Maybe the second one takes out just 3 fields, puts them somewhere else. And then adding that timestamp, adding a Latin long because they were in a weird format. And then once I have the data look familiar, send that to Pulsar, as many as I want to do here. I have it stopped. I don't lose data. There's a queue. Again, nice features to have in any of these examples. Pretty straightforward to do that. Very easy to write reusable components. So I should make this a reusable module and just add some parameters to say, okay, what Pulsar topic are you going to? What's your key? A couple of things I can specify, and then just have that as a reusable component that can be used by different sources of data, whether that's things like transit data or cloud status, IoT data, lots of different sources of data out there that you might want to work with, weather data, stock data, pretty easy to do different types. I don't see any chat or any questions yet. Hopefully this looks all very straightforward to everybody. Very simple thing here to take data from various devices and put it into the cloud, do that real time, analyze that data midstream. I've got links to more articles, more example code. If you're interested in Pulsar, I hope you are. Join our Slack group. Follow us on Twitter. We've got a monthly newsletter. No junk in it. It's just what's going on with the project, different resources, example code out there. Helpful to have. We've got some free summits coming out there. One very soon. I'll be talking on a different IoT use case on that one, and I'll be hosting a track there. Please join. It's focused on European time. These are still virtual, but fun event. There'll be a lot of good talks. We've got some talks from some other interesting open source projects that work with Pulsar there. Definitely keep in touch. And when we get to question and answers, if you don't have questions, I'll try to make some up and highlight some of that in the different tools based on what's going on. I think it's just about time to get into Q&A. I haven't seen anyone put any out there yet, but that could be coming. If you have anything, please put it in there. I don't know if it updates real time on my side or not.
Hey Tim, thanks a lot for the for the great walkthrough NiFi and Pulsar. I'm sure that people will find you. You're a little bit all over the internet, so I think if everyone has a question, I'm sure they will be able to find you online somewhere. Right now, it does seem like we don't have any questions in the pipeline. So yeah, I would just end this session, and thanks for closing up the
Sure.
day and for joining the conference and being part of it.
Well, thank you for hosting. It's been a pretty awesome event. Thank you. Let's finish it up.